Hi there. In this video, we're going to be doing some practice problems on solution stoichiometry. This video is a follow-up to an earlier video that I did that kind of went through some of the basics of solution stoichiometry. At the end of that video, I said I'd make a second one that would basically follow along with a worksheet. So I've created a worksheet as a Google form. You can find that link right down here. And what you may want to do is actually access the form, try the problems, and then if you have any issues with any of the questions, you can go to the specific part of the video, of this video, that deals with the question that you're looking at. Okay? So let's get started. The first question in that form is right here. It basically shows you a balanced chemical equation of zinc metal being put into hydrochloric acid. And if you do that, you take a chunk of zinc and you put it into HCl, what you see is you get a lot of bubbling and that zinc disappears. Well, that zinc metal is ionized into zinc 2+. And so zinc 2+ becomes, or zinc metal becomes zinc 2+ in the form of zinc chloride in an aqueous solution. Okay? The chloride is coming from the hydrochloric acid. The H in the HCl, during that reaction, the hydrogen forms hydrogen gas, and that's the bubbling that you see. Well, so let's imagine that we're doing that reaction, and the question that we're asked is how many grams of zinc can react with 44.9 milliliters of this solution of HCl, okay? So the first thing that we need to do anytime we start one of these problems, of course, is to figure out what the question is, right? Here's the kind of roadmap that we talked about in the last video, where you're starting with some measured amount of A, you're turning that into moles of A, you're using the balanced chemical equation to convert to moles of B, and then you're solving for some measured amount of B. So B is always the thing that you're looking for a measurement of. So it's how many grams, that's the measurement we're looking up for, that's the measurement that we're trying to solve for, of zinc. Okay? So the question that we're going to be asking in this problem is how many grams of zinc, okay, is equal to whatever the measured amount of A is. Well, A is the other chemical in this problem, so it's HCl. The measured amount of HCl is a volume of HCl, right? So it's 44.9 milliliters of HCl solution. Okay, and so these problems always, kind of follow this similar pattern. The first thing that we're going to do is convert this measured amount into moles. Well, what are we going to use to do that? We're going to use molarity. Okay, so remember, as we said in the last video, molarity is, I'll write that here, molarity is equal to moles per liter of solution. Okay, that's moles of solute per liter of solution. So this 0.240 moles per liter is going to be our conversion factor to get from a volume into moles. So the first step that we need to do here is convert this milliliters into liters. Okay, and so we can say that there's 1,000 milliliters in 1 liter of solution. So we've crossed out milliliters on the top and bottom. We're now in liters of HCl solution. Our next step is to go ahead and do this dimensional analysis to allow us to convert from volume to moles. And so we'll say that in every 1 liter of solution, there are 0.240 moles of HCl. Okay, that's what molarity is, right? So we've canceled out the units, liters of solution, in the numerator and denominator, and so now we're in moles of HCl, or moles of A, right? So our next step is to convert from moles of A to moles of B, and so to do that, we're going to look at the balanced chemical equation, and what we see is that there's a 1, right, in front of zinc, and a 2 in front of HCl. So it takes 2 moles of HCl to react with 1 mole of zinc, right? So that's our mole to mole conversion here. So we're going to say that for every 2 moles of HCl, will react 1 mole of zinc. Okay, so now we've done that step to get from, we've canceled out moles of HCl. Now the units that we have are moles of zinc, which is moles of B. Okay, so the last step then is to go from moles of zinc into the measured amount of zinc that we're looking for, which is grams. Okay, so in order to convert from moles to grams, what we're going to want to use is the periodic table. So we need to know the molar mass of zinc. Okay, so I've got a nice app on my phone that has the periodic table, right? Because I'm super nerdy. So let's look up zinc here. So we've got zinc, and zinc we see is 65.41 grams per mole. Okay, so our final thing here is to say that in every 1 mole of zinc, there is 65.41 grams of zinc. Okay, so moles of zinc and moles of zinc cancel, and so the only unit that we have left now is grams of zinc, and that's the original unit that we wanted, right? So now in order to solve this problem, we just need to run through the math. Okay, so let's do that. Okay, so we'll say 44.9 divided by 1,000 times 0.240 divided by 2 and times 65.41. Okay, and so what we get is that if we start with about 50 milliliters of this solution of HCl, we can react 0.352 grams of zinc. Okay, so the amount of zinc is going to be equal to 0.352 grams. All right. So this is a really classic kind of stoichiometry problem where we're starting out with a volume, and so we need to use molarity to get us into moles of that solute, right? So we use the molarity of that solution to get us into the moles of HCl, or the moles of A, right? That allowed us to move through our roadmap. Okay, I'll erase the board here and we'll try the next one. Okay, so I've got the board erased and our next problem up on the board. Our next problem, the second problem on the worksheet, uses the same chemical equation. It's the same reaction. Now we're just asking a slightly different question. So now we're saying how many milliliters of a now 3 molar HCl solution, okay? So now we're using quite a bit more concentrated solution of HCl. How many milliliters of that would be required to produce 0.115 grams of hydrogen gas? Okay, so in this question, it's how many milliliters. Okay, so that's going to be our measured amount of HCl. Okay, so B is HCl. So the question here is going to be how many milliliters of HCl solution okay, is equal to, so what is A? Well, A is going to be hydrogen gas, and the measured amount we have of A is this 0.0115 grams. Okay, so it's equal to 0.0115 grams of H2 gas, right? And so our first step is going to be to go from this measured amount of hydrogen in grams into moles of hydrogen gas, moles of H2, okay? In order to go from grams of H2 into moles of H2, what we'll need is the periodic table, and we'll need molar mass of H2, okay? So hydrogen has a molar mass of about 1.01 grams per mole, so H2 has a molar mass of 2.02 grams per mole. So I can say that in 1 mole of H2, there is 2.02 grams of H2, right? So grams of H2 in the denominator and in the numerator cancel, and we're in moles of A, okay? Our next step is to do a mole-to-mole conversion to go from moles of H2 into moles of HCl. If I look at the balanced chemical equation, I see that for every 2 moles of HCl that we react, we'll produce 1 mole of H2, okay? So it's 1 mole of H2 produced to 2 moles of HCl reacted. All right? And so now moles of H2 and moles of H2 cancel, and so now we've got moles of HCl, or moles of our B. All right? And so now we want to go from moles of B into measured amount of B. Well, look what the unit or the type of measurement that we're trying to get to. It's a volume, okay? A volume of solution. So anytime we're trying to convert from moles to volume of solution, moles of solute into volume of solution, we're going to want to use molarity. So in this case, we know that our molarity is 3 moles per liter. All right? And so what I can do here is say that there are 3 moles of the HCl solute in every 1 liter of solution. Okay. So now moles of HCl and moles of HCl cancel, numerator and denominator. And so now the unit that I'm in is liters. Well, we're so close, right? Because we're asked for milliliters of HCl solution. So we just need to do one more step. We need to convert liters of solution into milliliters of solution. So we can say that in 1 liter of solution, there are 1,000 milliliters. Okay, so liters and liters cancel. And so now we'll have milliliters of HCl solution. Okay, and so that's the unit that we want to be in. So now we can just run through that math. Okay. All right, so we'll say 0.0115 grams divided by 2.02 times 2 divided by 3 times 1,000. Okay, and so we get 3.79. How many? I'm looking for 3 significant digits. So let's say 3.80 milliliters. Okay, 3.80 milliliters of our HCl solution. All right. Okay, so that's number 2 on the worksheet. Let me erase the board, and then we'll start again on number 3. All right, so fresh problem up on the board, and a new reaction here. In this reaction, we're taking 2 solutions, silver nitrate and NaCl. This is a similar reaction that we did in the previous video. Instead of using NaCl, we were using MgCl2, magnesium chloride. In either case, the silver and the chloride in this double displacement reaction, the silver and the chloride form this insoluble AgCl compound. Okay? And what's left in solution after they precipitate is sodium nitrate. All right, so it's 2 clear solutions. You pour it together. You have a solution of sodium nitrate with solid precipitate of silver chloride. All right, and so the question is, how many milliliters of an AgNO3 solution react with 14 milliliters of a 0.75 molar NaCl solution? Okay, so what's going to be our A and B in the roadmap? Well, B is what we're looking for, right? And so we're looking for a volume of AgNO3 solution, okay? So our question is how many milliliters of silver nitrate solution, okay, will react with a measured amount of A. So 14 milliliters, another volume of NaCl, okay, is equal to 14 milliliters of NaCl solution. All right, and so in both cases, our measured amount of A and B are volumes, are both volumes. Okay, and so in order to convert from volume to moles, we'll need molarity, and in order to convert from moles to volume, we'll need molarity. Okay, so in each case, the dimensional analysis here is going to involve molarity. All right. So in our first step, we're going to want to use the molarity of this NaCl solution, right? And that NaCl solution has a molarity of 0.75. Okay, so that's 0.75 moles of NaCl solute in 1 liter of solution. So the first step, like kind of normal, is we typically see volumes in milliliters, And so we need to convert that milliliters into liters, right? And so we can say that, well, there's 1,000 milliliters in 1 liter. Milliliters will cancel, and now we're in liters of NaCl solution, okay? So now we're ready to do this step using molarity. And so we can say that there are 0.75 moles of NaCl in 1 liter of that NaCl solution, right? So liters of solution and liters of solution cancel. Now we're in moles of A, or moles of NaCl. So our next step then is to do a mole to mole conversion. Well, the kind of nice thing here is that everything just has a 1 in front of it. So 1 mole of NaCl reacts with 1 mole of AgNO3, okay? So we can say 1 mole of NaCl, 1 mole of AgNO3. Okay, so moles of NaCl in the numerator and in the denominator cancel. And now we're in moles of AgNO3, or moles of our B. Okay, and so now again, to get from moles of B to volume of B, we need the molarity of this AgNO3 solution. Okay, well, we're given that. We're told that that solution has a molarity of 0.21, right? So we can say, remember, moles of AgNO3 are on the top here. So we want moles of AgNO3 to be in the denominator of this next one, right? So it's 0.21 moles of AgNO3 in every 1 liter of AgNO3 solution, okay? So moles of AgNO3 in the numerator and the denominator cancel. Now we're in liters of solution, right? So I have one last step. I need to say that in every 1 liter of solution, there's 1,000 milliliters of solution, okay? Liters and liters cancel. So now I'm in milliliters of AgNO3 solution, all right? And so now we just need to run through that math like before. So my calculator here, so we start with 14 mils. We divide that by 1,000. We multiply by 0.75. It's a 1-to-1 ratio here, so then our next step is to divide by 0.21 and then to multiply by 1,000, okay? So our answer here is 50 milliliters. So this equals 50 milliliters of AgNO3 solution, okay? So just keep in mind, in both cases, in order to get from amount to moles, or to get from moles to amount, in this particular problem, we needed molarity in both of those cases because A and B are both solutions, okay? I'll erase the board here and we'll try our 4th problem. All right, so our final question on the worksheet here, again, uses the same reaction. And in fact, this time we're still using the same volume of NaCl solution. It's just this time we're asking how many grams of silver chloride would we produce if we used this volume of this NaCl solution, okay? So again, our first thing to do is to decide what our question is, and our measured amount of B, it's how many grams of AgCl, okay? So it's how many grams of AgCl are produced from a measured amount of A, are produced from 14 milliliters of NaCl, all right? So 14 milliliters of NaCl. So our first step is we need to convert our measured amount of A, our measured amount of NaCl, into moles of NaCl. Well, since NaCl is a solution, okay, then in order to go from volume to moles, we'll need molarity. So it's 0.75 moles per liter, okay? Moles per liter, right? This is milliliters. So really our first step is to say that in 1 liter, there are 1,000 milliliters, okay? So now we're in liters of NaCl solution. And so now we can use molarity to say that in every 1 liter of solution, there are 0.75 moles of that HCl solute, right? So liters of solution and liters of solution cancel, and now we've got moles of A, moles of HCl. Okay. Now we can use our mole to mole ratio here, the fact that everything is 1 to 1, so it's 1 mole of NaCl produces 1 mole of AgCl, right? So we can say 1 mole of HCl will produce 1 mole of AgCl. Okay, moles of HCl and HCl cancel, and now we're in moles of AgCl, or moles of B. Right? So our final step is to go from moles of B into our measured amount of B. We're looking for grams, so if we want to go from moles to grams, we're going to need molar mass. Okay, so we need molar mass of AgCl. Well, if we look on our periodic table, Ag has a molar mass of 107.87 grams per mole. Cl has a molar mass of 35.45 grams per mole. Okay, so this is 143.32 grams per mole. Okay, that's our molar mass of AgCl. Okay. So our last step here is we can say, well, in 1 mole of AgCl, there are 143.32 grams of AgCl. Okay, so moles of AgCl and moles of AgCl cancel, and so now the only unit we have left, grams of AgCl, is the unit that we were looking for. So, like before, we'll run through that math real quick. So we'll say 14 milliliters, divide that by 1,000. So now we're in liters, multiply by 0.75. We're in moles of HCl. Moles of HCl, it's the same as moles of AgCl. And so our last step then is to multiply by 143.32. Okay? And so we end up with 1.5 grams of AgCl. All right, so I hope this video on solution stoichiometry was helpful. Thanks for stopping by. I'll see you again.